Have you ever looked up at the night sky and felt a pull? A yearning to know what came before us and what will come after? To witness the Big Bang, the first stars, or the universe's final breath? These are not just scientific questions but deep human desires. We are bound by time, born, living and fading away, carried forward on a one-way river. But what if time isn't a straight line? What if all of time exists at once? A cosmic landscape where dinosaurs roam in one corner and our descendants explore galaxies in another. In this view, time is a place, not a sequence, a destination we could, in theory, visit. The past isn't gone, it's still happening somewhere. The future isn't unwritten, it's already there, waiting. This is the block universe, a static, four-dimensional reality where we experience only slices, moment by moment. But if all of time exists, why do we only remember the past, not the future? Why does time seem to flow one way? The laws of physics work forwards and backwards, yet our experience is one way. Eggs don't unscramble, broken glasses don't reassemble. Our journey through time seems to have a strict one-way rule. To understand if we can ever break this rule, we must first understand the very nature of time itself. Is time a river or a landscape? Is the future already written, or do we create it as we go? These questions are at the heart of our quest to understand reality. The answers may change everything we know about ourselves and the universe. Let's begin our journey to unravel the mystery of time. For centuries, time was seen as absolute, a universal clock ticking the same for everyone. Newton imagined it as a cosmic metronome, unwavering and true. But Einstein shattered this idea. He saw time as flexible, relative, woven together with space into space-time. Picture space-time as a giant trampoline. Massive objects create dips, which we feel as gravity. But gravity doesn't just bend space, it bends time. The stronger the gravity, the slower time flows. Time is not immune, it bends and stretches depending on where you are and how fast you move. This is time dilation, a real, measurable effect. GPS satellites must adjust their clocks, because time runs faster for them than for us on Earth. Even living on a skyscraper's top floor makes you age a tiny bit faster than on the ground. The faster you move, the slower your time ticks. Travel near light speed and you could return to Earth after a few years to find centuries have passed. This is not science fiction, it's a consequence of the universe's laws. Einstein gave us the keys to the future. The river of time has fast and slow currents. We can, in principle, travel forward in time. The challenge is engineering, not physics. The door to the future is open. But what about the past? Can we ever turn the arrow of time around? That's where the real mystery begins. Einstein's equations show us a clear path to the future, a one-way ticket, but a ticket nonetheless. Orbit a supermassive black hole, and time slows to a crawl return, and you've leapt into the future. This is time travel, predicted by physics, limited only by our technology. Even flying in a jet makes you age nanoseconds slower than those on the ground. The path to the future is open. We're all time travelers, moving 1 second at a time. But can we go back? Here things get complicated. The laws of physics are mostly time-symmetric. They don't care which way time flows. But our experience is ruled by the second law of thermodynamics. Entropy always increases. The universe moves from order to disorder. Sandcastles crumble, eggs break, not the other way around. This is the arrow of time. Reversing it would mean reversing entropy, unbreaking eggs, unspilling milk. While relativity allows for closed time-like curves, paths that loop back in time, they clash with the relentless march of entropy. The universe seems to prefer moving forward. Reversing our course on the river of time may be impossible. The laws of physics allow for forward travel, but the past remains elusive. The arrow of time, it seems, is not so easily bent. Suppose we could travel back in time. The first problem isn't technical, it's logical. Enter the grandfather paradox. Go back, prevent your grandparents from meeting, and you erase your own existence. But if you were never born, how could you go back in time? This contradiction threatens the very logic of reality. If the past can be changed, causality collapses, the universe unravels. How does reality resolve this? One answer, the self-consistency principle. The universe won't allow paradoxes. Any action you take in the past was always part of that past. Try to stop your grandparents from meeting, and you'll fail, by fate, chance, or your own actions. You can't change the past because you're already part of it. Another possibility, the many worlds interpretation. Every paradoxical choice splits the universe. Create a new timeline where you were never born, but your original timeline remains unchanged. You become a visitor in a new world, unable to return to your own past. In this view, there are no paradoxes, just infinite parallel universes, each with its own story. The past may be fixed or endlessly branching. Either way, time travel to the past is fraught with paradox and possibility. The universe may be stranger than we can imagine. To travel through time, we need more than speed, we need a shortcut, a wormhole. A wormhole, or Einstein-Rosen bridge, is a hypothetical tunnel connecting distant points in spacetime, or even different times. Accelerate one mouth of a wormhole near light speed and time dilation creates a time difference between the ends. Step through and you emerge in a different era. A time machine in theory. But there's a catch. Wormholes are incredibly unstable. They'd collapse instantly unless propped open by exotic matter with negative energy, something never observed in nature. Quantum effects hint at negative energy, but we don't know how to harness or stabilize it. Without exotic matter, traversable wormholes remain theoretical. The gateways to the past may be forever closed, yet the mathematics of relativity keeps the dream alive. The universe may still hold surprises. What if time itself is an illusion? Some physicists and philosophers suggest our sense of past, present, and future is a trick of consciousness. In the block universe, all moments exist simultaneously like a DVD, with every scene present at once. Our minds experience time sequentially, frame by frame, creating the sensation of flow. The past isn't gone and the future isn't yet to be, they're just different locations on the cosmic DVD. In this view, you can't change the past, your presence was always part of it. The grandfather paradox dissolves your existence, proves your grandparents met. The universe is a complete story, and we're reading it page by page. This challenges our sense of free will. Are we actors in a script, or do we shape our fate? Perhaps the universe is deterministic, every event inevitable. It's unsettling, but it paints a picture of a unified, timeless reality. Maybe time is not what we think it is at all. So where does this leave us? Physics permits travel to the future, but the past is guarded by paradox and entropy. Technologies like wormholes may be forever out of reach, or may one day surprise us. Perhaps the universe has a built-in safety net preventing paradoxes or shunting travelers into parallel worlds. Or maybe time is an ocean, not a river, a block universe where every moment is equally real. We are not moving through time, we are patterns that extend across it. Our lives are not fleeting journeys, but complete shapes in the four-dimensional whole. Your birth, life, and death are eternal features of the universe. In some sense, you have always existed and always will within spacetime's tapestry. The quest to understand time is a quest to understand ourselves. Whether we ever build a time machine, we are already time travelers. Through memory, through hope, through being. We are not just moving through time, we are time.